Okay, so our warm-ups involved the two conics we've already studied. Which one's the circle?
The first one.
Why do you know that?
Because there's two variables.
They're both squared. They have the same coefficient, and it's a sum. Okay, what is the second one? A parabola, and how do you know?
One squared.
There's only one square. Good. All right, so let's take a look at these. So the first one, what I did first, I divided everything through by 2. And then what I got was x squared, and then negative 10x divided by 2 left me with a negative 5. Then I had to complete the square here and here. And then I divided this, and I got the y squared minus 9y. And then I divided the 1 by 2, and I got 0.5. So then I took half of these and squared it, half of this and squared it. And then I added that to both sides. So when I took half of the 5, I got the 2.5. And when I squared it, I got the 6.25. When I took half of the 9, I got 4.5 and squared it and got 20.25. So when I write it as perfect square, when I take the perfect square trinomial and factor it into the binomial squared, you get x minus the 2.5 squared plus y minus the 4.5 squared equals 27. So the center is opposite, 2.5 comma 4.5. And the radius is the square root of 27, which is slightly more than 5, right? The square root of 25 would be 5. Okay, did you add 6.25 and 20.25?
To 1/2.
To 1/2. No. Okay, that's where the issue happened. Did you add the 6.25 here and the 20.25? You may have written this as 5/2, so you may have written this as 25/4.
Yes.
And then did you write this as 81/4?
Yes.
Okay.
Then I multiplied it by 2 because you pulled the 2 out.
Oh, so you didn't divide by 2 to start with.
No.
Okay. So yours, you would have had to divide by 2 both right here. Did you have 54?
Uh-huh.
Then you should have divided by 2 there.
Oh, okay.
And turned it by 27.
Do you want us to graph it?
I wanted you to tell me everything about it. So for the circle, all we know is the center and the radius, and sketch the graph. So it would look something like this. All right, this one we complete the square, and this was a little easier to complete the square. There's an understood 1 as our coefficient here. You don't really have to write 1 as your coefficient, but it's understood. The only reason the 1 helps us is to find the p. We know that 1 equals 1 over 4p, so p has to be a fourth. So if I plotted my vertex at negative 6, 1 here, I know this is x equals, and it's positive coefficient, so it's going to open right.
Why was
So
that,
I,
why was that negative 5 turned to a positive 5?
because I had to move it to the other side to complete the square. I moved it from this side of the equation to the other side.
Where'd you get the 1
Oh,
from?
because I subtracted the y.
I got the
squared,
1 when I was completing the square.
and then I subtracted the x squared, and I got like the same answer except for the coefficient. I got plus 4.
Okay, I'll come look at your work in a second. All right, so take a look at that and see if you have any questions.
Okay, I remember it. Kind of.
It's like,
Wait, no, he knows how.
Check my book profile. I wouldn't know.
it's the one that
Oh, okay. So you added 1 here, but there's a negative out in front.
Yeah, that's true.
So this is just really a
Well, at
negative.
least you're doing
To the other side, so that's where it happens.
The p, which is the distance from the invert.
Like doing bad with it.
Yeah.
P is the distance from the.
Vertex to the focus and the vertex to the directrix.
Thank you. Those are the words.
Mhm.
And so times
So I guess that what I didn't write was those. So the focus
y minus whatever it is.
would be the point negative 5 3/4,
Because in front is a.
1, and the directrix would be the line x equals negative 6 1/4. There we go. All right, so I left out those 2 little pieces of information.
So how do you get the focus again?
We know that the focus is going to be whatever this coefficient is, which is 1. So it's 1 equals 1 over 4p. So when we solve, we get p equals a fourth. So the focus is going to be 1/4 inside. So I'd add 1/4 of that. And the directrix is 1/4 outside. Yeah. Okay. Any other questions? All right. Today we're going to talk about the ellipse. And I'd like to show you a few things about the ellipse. That is not the first one I want to show you. All right. So the ellipse. Why study ellipses? So the first thing we have here is it shows us that orbiting satellites, including the Earth and the Moon, trace out elliptical paths. So that's kind of cool. Many buildings and bridges use the ellipse as a pleasing and strong shape. So here's a bridge that has an elliptical support here. Okay, now this is pretty cool. One of the properties of ellipses is that sound, or any radiation, beginning at one focus. So ellipse has the two foci. So if we're looking at one of the focus, it'll be reflected so that it can be clearly heard at the other focus. You can see this working here. So it bounces off and it lands at the other. Does anybody know of any real world application?
When you're in a tunnel.
You know what? It can be when you're in a tunnel. If it depends on the shape of the roof line. Have any of you been to the Whispering Hall at the Capitol?
No.
With an elliptical shaped dome?
Wait, is that?
And where you can stand at one point and whisper, and a couple 100 feet away somebody can hear you, even when there are people in the hall?
That's kind of creepy.
Mm-hmm.
Is that what they
It is because, yes. And I can't remember who it was. Was it Thomas Jefferson that had a desk at one end or something so he could hear? I don't remember.
It's kind of sweet though.
I can't remember. I may be giving you inaccurate information here.
Colors change.
Well, there's to make it pretty. The colors don't need to change. Okay, so that is one property. Yeah, it's just making it pretty. It's the reflective property of an ellipse. So that's pretty cool. Now, this is also showing you the same thing, that when we emit from one of the foci, do you see they all bounce to the other focus? So when we emit something from one focus, do you see how it centers in on the other focus?
Yep.
And this is helpful in some applications, and what I have here is an explanation of how it's used to bust up kidney stones. Mm-hmm. So it's a special, it says the ellipse is a special and practical conic section, and one of the important properties is its reflective property. So it's true of light rays and other forms of energy, including shock waves. And this is nice because shock waves generated at one focus will reflect off the ellipse and pass through the second one. And this is unique to the ellipse. And it's used
So it's a kidney ellipse.
by specialists to create a device that treats kidney stones. So what this does is it uses shock waves to shatter this kidney stone into tiny pieces. And it's known as this word. Who's good at pronouncing medical words? Okay, that sounds good. And then down here,
Pronounce everything wrong.
it says that the machine that's used to do this is a half an ellipsoid shaped piece that rests on the patient's side. And the ellipsoid is a three-dimensional representation of an ellipse. So in order for this to work, using the reflective properties of ellipse, the patient's stone must be at one focus of the ellipsoid and the shock wave generator at the other focus. And then the patient is laid on the table and moved in motion. And then the doctors use an X-ray system to maintain a visual of the stone, and it allows for accurate positioning of the stone as the focus. It says because the stone is acting as one of the focus points, it's imperative that the stone be at the precisely right distance from the focus. So they would have to set you up just right. And then they would send in the shock waves, and there's the machine. Pretty cool, huh? All right. So now by definition, and we'll go back to this one. By definition of an ellipse, the way we can make it is this distance from one focus to a point on the ellipse to the other focus remains constant. So let's say this was 10 units. Well, if that is 10 units, then the one over here would also be 10 units, no matter how we drew it in. So now let's go to our worksheet so I can actually do that. So if I went from one focus to another, and we don't have a focus here, but I'm going to just guess that they would be about right there. Don't draw this part. I don't want you to get your things too cluttered. But whatever this distance is, any way I connect this distance, the sum of these two, and the sum of those two are the same. And the sum of these two would be the same. The sum of these two distances are always equivalent. And that's how we form an ellipse. So it says the ellipse is a set of all coplanar points such that the sum of the distances from the two fixed points called the foci is constant. And that's how we form it. Now we're going to talk a little bit about the equation of the ellipse. And just like before, you figured out the first one was a circle because it had two squared variables, it was a sum, and they had the same coefficient. And you know it's a parabola because there's only one squared. Now, we can know it's an ellipse if they are both squared. You see again. Both squared. It is still a sum. So it looks like a circle so far. But the difference between the circle and the ellipse is that they have different coefficients. And that's what takes it from being a radius that's exactly the same all the way around to being elongated in one direction. So it's either going to be elongated horizontally or elongated vertically. And because they have these different coefficients. When they have the same coefficient, that keeps that constant all the way around and makes it a circle. But when they have different coefficients, it's elongated. So this one's elongated horizontally, and this one is elongated vertically. And after we study hyperbolas, then we're going to talk about eccentricity. And that tells us about the roundness of our conic section. All right, so this one is elongated horizontally. So whatever is under our x, the square root of that, gives us our distance from the center to the endpoints of this axis. And when it's elongated horizontally, that axis is called our major axis because it's the bigger one. And so that distance would just be the square root of a squared, so it's considered a. So the vertical axis is considered our minor axis when it's elongated horizontally. And the distance from the center to the endpoints of the minor axis is b, the square root of what's under our y's. Our center is found the same way it was with the circle, so it's going to be hk. The length of the major axis. Well, if this distance is a and this distance is a, then the whole major axis would be what? 2a. And what would the length of the minor axis be? 2b. Now, our foci. Our foci is going to have to somehow represent, we would call this our foci. And the distance from the center to the foci we call c. So c represents the distance from the center to both of our foci. And the way we get it is we're subtracting our denominators and taking the square root. And when it is elongated horizontally, the foci is going to be, we would take that c and add it and subtract it to our x, because the foci will lie on the major axis. Now our vertices are what we call the endpoints of our major axis. And when it's elongated horizontally, it's going to be h plus or minus a. And our co-vertices,
Plus or minus
it's going to be HK plus or minus what?
B.
B. Good. All right, so not much changes when it's elongated vertically. We still have our center. Our foci will now be on the vertical axis. This distance is still A, and this distance is still B. But what's going to switch is what we call major and minor vertices and co-vertices. So our center is still the HK, but what would the length of the major axis be if we elongated it vertically?
2B.
2B. And what about the minor? 2A. And to find the foci, what would we add that C to?
Okay.
HK plus
Good.
C.
And to get our vertices, what do we add? Where do we add it?
HK plus 1 is K.
Okay, K plus or minus B. And our coverts would be H plus or minus A.
How long is this unit going to be?
2 weeks. Our test is in 2 weeks. So we're going to, basically, all we have are 2 more conics. We've already done circles and parabolas, so we have the ellipse and we have the hyperbola. But we're going to do a lot of practice with them, a lot of word problems with them. We have a day where we get to go outside and draw them.
Outside.
Oh yeah, if it will ever be a pleasant day. But I have to teach you all of them before we can go outside and draw them. All right, so we have a couple examples. The first one, I can tell it's an ellipse because it's squared, some different. All right, if you want to go ahead and write down the example, I'll give you a moment to do so, and then we'll talk about it.
Should we start working on it?
No, I will do it with you. Okay, so which way is this one elongated? Horizontally or vertically? Horizontally. How do we know?
Bigger.
The bigger number is there. All right, where is my center?
2. Negative
2, negative 1. Okay, so if I wanted to graph this, I would come over to 2, negative 1 and start with my center. Okay, now horizontally, how far in each direction do I move from the center? Okay, we're going to do the square root of this. So our A is 3, so we're going to move 3 in each direction. So our vertices are going to be adding 3 and subtracting 3 from the 2. So it's going to be negative 1 is one of our vertices. And then it would be 5, negative 1. So those are our vertices.
Our co-vertices.
All right, now what about our coverts? What do we add and subtract?
2.
2, and what do we add and subtract it to? The y's. We just go up and down 2. So it's going to be, whoop, wrong spot. 2, 1, and 2, negative 3. And those are our co-vertices.
Beautiful.
Okay, it's beautiful until I try to draw it. And then to the best of your ability, you would draw an ellipse. My ability is very much lacking on an ellipse.
Looks like a raw miss mine does.
Yay!
Potato.
It's not an ellipse.
No, mine is not an ellipse at all.
It's a barely follows.
But it's my best attempt.
No, I don't understand.
Is there an elliptical drawing tool in here? Yeah.
Oh, perfect, almost.
Huh.
It's lacking.
Oh no, it joined them. Did it really join them?
Okay, now I get it.
I'm so like fascinated by this.
It's almost as if she had a tool.
There we go.
It's perfect.
Is everybody happier now? Alright, so there's our lips, and that one's much
How do we
better.
do that on paper now?
I know. Now, y'all make yours look just as good as mine, and everything will be
And
good.
if you don't, you fail.
Alright, so our foci need to be on this major axis here. They need to be on the major. So I have to find that C. Well, since C squared is going to be, it's always the bigger number minus the smaller number. So in this case, the bigger number is the A. So we're going to do A squared minus B squared. So C equals the square root of 5. So that is the distance from the center to our to a focus. So I would add and subtract that to my x value. So if you want to write it this way, I'm good with that. Because that really means 2 plus the square root of 5, negative 1, and 2 minus the square root of 5, comma, negative 1. So that's where our foci are. Okay. You try the next one.
Are you sure you trust us to do this?
I do. And you still have my example to look at. I think you can do it.
Are you excited for the weekend, Miss Willoughby?
I'm excited for the weekend. Yes.
You believe we only have 16 days, including today?
Can you believe I got my license in 17 days?
I am slightly concerned because my children are super excited about spring fling this afternoon, but I'm a little concerned about the wind and the weather, about
Oh,
whether
it's
they're
today?
going
Um,
to put up all the clothes.
Babies
Like
were
the
talking
my
about
brother's
it, and I was
excited
really
too.
so excited. Spring fling was like the highlight of my life.
But us it was like called like Spring Fest, right? Yeah, Spring Fest.
I told them I would take them to Chick-fil-A whether or not we had spring fling today.
My
Does that
dad
make
got
them
to,
happier?
my dad worked in construction and he made it so that everyone pretty much everyone liked to make it.
I would.
So it wasn't like doing
You want I would never want to be adopted. Like, I want my parents.
missing everyone.
Like, I'd be sad.
Just like
I
pressing
mean, I'd be
buttons.
sad, but then you have to miss this.
I don't know if you gotta make it feel good.
Like, they let me do so much stuff. Like,
Well, yeah, because you don't do anything.
huh?
Deal with it.
I feel like you feel yourself because you don't really do anything.
Thanks.
You're like so innocent. You can
Okay, are we working? Let's work.
Because the first time we were adding one, the equation is x minus h.
Ours are pretty rad.
Okay, that's weird.
I'm gonna for the random one, but then I figured I
I need one more project, and I don't know
Did you tell
when.
them?
I need one more
Yeah, I
project
did
and
tell
5
them
more
I did.
hours.
I'll work at the dog park this weekend. Oh, did you say you needed more hours?
Yeah,
To
but I
grid
need
when you do that. I have to do gate
Okay,
cars.
because this is excellent.
Wait,
This
where
is
it?
not
That
what
dog
you
park
did.
guy, you know the BMX track? What
time would it
Like a second, and do that in a second. All you have to do is gate cars to that.
Oh, it's. Oh, okay.
It's great because I live right by.
you like you just show up there.
Then you show up, sit down.
100% because it's C
you
squared
or
minus B
something.
squared.
People walk by,
Enjoy
like,
your
you check
Or
their
C
numbers,
squared equals.
their numbers, they just figure it out.
Because we have a social event.
Social event.
I'll let you know next week.
Probably one.
Special this weekend?
You can email.
Oh.
I think tomorrow night they have Dancing with the Stars at the auditorium. It's a fundraiser for charities, and my son's teacher volunteered to do it. So, Miss Thomas, did any of y'all have Miss Thomas at elementary school?
I've heard. I've known about her.
She's fabulous. So, I think I'm gonna go support that.
Yeah.
Can you go over the photos? I only know
I sure can. All right, to get the foci,
Miss France.
here's the shortcut. Okay, shh, guys, I need y'all to be quiet for a second. Always take the biggest number, subtract the smaller number. You don't even have to worry about what order they're in. Biggest minus smallest, and take the square root of that. So that gives us C, which is the square root of 12, which is 2 root 3. Now, it's always added to what's on the major axis, so this time it's vertically, so I have to add and subtract that to my Y at the center.
Okay.
If it was elongated this way, you add and subtract it to your X at the center.
Okay.
Okay?
Miss Wilby. Are logarithms part of math 3?
Yes. So over the next couple of days, we're going to be doing ones where I give you some of the information, and you have to come up with the equation. So let's say I tell you it's an ellipse that has a center at the origin, and I give you.
Graph 3? I used the logarithm on the EOCT.
You probably didn't have to, but you already knew how to do it, so you could have probably written it as like basis, but that's fine.
Okay.
Oh, I had to do one of those too.
Okay. All right, so an ellipse with a center at the origin that has, they only give us one of the vertices, so we have one vertex is this, and one of the foci, they give us one focus, and I'm asking you to write the equation. So let's just kind of take a look at what this might look like. Huh, that's a really good straight line, isn't it? There we go. It is a straight line, it's just not vertical. You are correct, it is a straight line, just not vertical.
Oh, man. Technicality.
All right, so I'm going to plot on my little axis here the origin, and I'm going to count by 2's. So this would be -2, -4, -6, -8, -10, -12. All right, so I've got a focus here, and I've got a vertex there. So since I called this a vertex and not a co-vertex, I know this is the major axis, don't I? So let's start with what I need. I need x minus my x value at the center. Well, the center is at 0, 0. So it's going to be x squared plus, well, that's the origin, y squared. Now with an ellipse, it must always equal 1. And I just have to figure out that a squared and the b squared. Well, I know this is my major, and that distance from the center to the endpoint of the major axis is 13. So that's my b. So under here goes 13 squared.
So it's 169.
Correct. Now what I have to figure out is where's the one over here? What would a be?
You have to do it backwards.
We do have to do it backwards because I know that c squared is going to be equal to b squared minus a squared. I know that c is 5, right? The distance from the center to the focus is 5. So this would be 25 is equal to, well, I also know this distance is 13. I know the b is 13. So this would be 169. Ooh, I squared it and I put a square. Sorry. So that would be 25 equals 169 minus a squared. So negative 144 equals negative a squared. So 144 equals a squared. So 12 equals a. But what goes under here is a squared. So it's going to be x squared over 144 plus y squared over 169 equals 1. And we're going to do several like that where you're given different pieces of information. There's some like that on your homework.
Lovely.
Now, the last one is not in the right form, but it is an ellipse. How do you know?
There's different coefficients.
There are different coefficients, squared, and a sum. So what do we have to do with these? We put it in the right form.
Yeah. Subtract
Okay.
71 first. And
So,
add
go for it. You know how to put it in the right form. Complete the square.
I thought we were telling you how to do it.
I know.
Wait, then how do you get the...
All right, we'll do it together. That's fine. That's fine. You
Sorry.
twisted my arm. Okay, so I'm going to group everything that needs to be grouped
Yeah. Add 71.
and add the 71 to the other side. All right, so I have to factor out the 9 here.
9.
To factor out the 16 here. Okay, so what do I add here?
1.
1. But it's really 9 times 1, so what do I add here? 9. What do I add here?
2.
4. Take half and square. 4. So I have to add whatever here.
64.
64. So I'm going to get 9 times, what does this become?
X minus 1.
Good.
Squared.
And then 16 times,
1 minus 2.
and this equals 80 plus 64 is 144.
That's a nice number.
It is it's a really nice number. Because an ellipse must equal, what did I tell you a minute ago? 1. So I'm going to divide by 144. Let me change colors. So whatever I do to one side of the equation, I must do to everything on the other side. And then something cool happens. And it happens just about every time. Not every time. But just about every time. Because 9 goes into 144 16 times. And 16 goes into 144 9 times. Do you see how it just kind of swapped?
That is lovely.
It is lovely. Now, it doesn't happen that way every time, but most of the time it does.
How do we
And there's our equation. Oh, you'll see. You'll get some. Okay. You have the remainder of class to work on your homework. It's out of your textbook. Go on page 222, numbers 2, 4, 12, 15, 24, 34, 35, and 38. That's also on the calendar online.